We have an hour today in order to look at the really interesting and complex issues related to smart and connected communities. So in the interest of time, we've printed out copies of everyone's bios because we have an extremely impressive panel of speakers today. And so this is just a brief overview. You can find more information about them online. But each of the panelists this morning will start us off with a brief presentation so you can get to know them a little bit through their work. And then I am going to try and keep them on time so that we have some time for discussion following the presentations. So we will begin this morning with a presentation by José Duarte, who is the chair of Design Innovation and director of the Stookman Center for Design Computing. And he is going to start us off by looking at some of the context and broader questions related to smart and connected communities. We will then have Param Sankar pick up. He is a senior project manager with Battelle. And you wouldn't know it to look at him, but he has over 20 years experience and a track record of leading people and projects to solve problems. And so he'll be looking at his experience stems from his background as a transportation engineer and his experience with Disney Parks and Resorts, as well as work with DataWorks, a big data technology startup, and he'll be looking at issues of data acquisition and use, policy, and technology. Following that, we have Cleo Andrews, who is an assistant professor here in geography and an affiliate of ICS, and she directs PSU's Friendly Cities Lab. So she's going to talk a little bit about data-driven love, which I'm very excited to hear. And then Daniele Quercia,
yes,
sorry,
so good.
will from the Nokia Bell Lab in Cambridge, will be expanding on that topic. He is Fortune Magazine's 2014 one of their data all-stars, and has looked at issues of happy maps for the influential TED Talk series. So he is going to expand on that topic of love into what he calls fuzzy concepts, and hopefully open it up to some broader discussion from the audience and among the panels to look at this topic of smart and connected communities more closely. So José, I will give you the peace sign at 2 minutes.
Okay,
so you
I
can
better
wrap
hurry.
it up at that point.
So good morning, everybody. My presentation, the goal of my presentation is to talk a little bit about the notion of smart and smart community. So I will lay down,
The video maybe was moved a bit.
So I have no idea what went
It
wrong.
was working until now.
You didn't like my voice. I hopefully will come up. So what I'm going to do is to show some of my previous work and the work of my students, and trying to explain what I mean by smart. So what is a community? So a community for me is a set of people on a built landscape that sits on a natural landscape. So we have three things: people, natural landscape, and built landscape. And what is smart? So for me, smart is being sensitive to the context. So we need something to sense the world, so we need sensors. We need to reason about the world, so we need an interpreter and a decider, so a control mechanism to decide what we are going to do. So we need to act on the world, so we need actuators. So it's a system with these three basic elements. And the goal, like in nature, is to strive in a changing world. So let me draw a parallel with nature to explain this idea a little bit better. So this is the DNA chain, so it's a code that if we can manipulate to generate different living creatures that are adapted to their environments. So what I'm talking about is to develop a similar idea, but into the realm of architecture and urban design. So this is the basic conceptual model. So we have a design system that reads the context, generates a solution, and has a way of materializing the solution through a production system, and we are using computers to connect the large data to interpret the context, generate a solution, and build the solution. So let's focus on the design system part. So we have 4 subsystems: a formulation system that reads the context and generates what we in architecture call the design brief. And then we have a generative system that according to a set of rules generates candidate solutions that closely match the design brief. But then we need a way to to rate and rank the solutions, so we need an evaluation system. And the problem becomes one of finding the optimal solution or the best solution for the given context. So let me show how this works in architecture. This is, the topic of my PhD dissertation then, about 20 years ago. So this was from the mass customization of housing. So we have a set of houses. We can infer rules. And then once we have these rules, we can generate solutions by applying the rules. And we generating them in such a way that they closely match the context. So we are designing houses for people, so for a household, they have a certain profile. On a specific location, they have specific environmental qualities. So the idea is this one, a set of rules that we can generate stuff, a way of evaluating different alternatives, and a way of choosing the best one. So we can actually create a very diverse and rich environment adapted to the context. So let me elaborate a little bit further. So this is what we call a set of rules based on the work of the great American architect, Frank Lloyd Wright. So he's able to generate candidate solutions, and what we are trying to do here is to find the configuration that minimizes the consumption of energy. So we have different possibilities, and we're looking for one. In this case, it's energy, but you could look for other viewpoints as well, trying to optimize the solution, find the optimal solution. Let's move on to the urban design level. So it's a little bit more complicated because we're dealing with a bigger scale, so the range of problems and the complexity increases, but it's more or less the same schema. In this case, we are using a GIS to gather data, and then a CAD system to interpret and act on the data. Just to illustrate how this works. So we have a site, we have a set of rules, we use the rules to generate candidate solutions. This is one solution among millions of possible solutions, and what we want is to find the best optimal solution. What we need? We need an ontology to describe the environment in a very consistent and systematic way. And then we need the 4 systems. Let's see how they work. Hopefully this will work. So the first one is a platform that you can use to gather data from the context, interpret this data to generate the design brief, in this case the program for the urban intervention. So it gives you some feedback about what we are doing. For instance, it can come up with things like this. So we are designing a settlement for 5,000 people, therefore you need a primary school, or therefore you need a health center, and so on. So it helps you to come up with different possibilities. Obviously, you also need a way to find how to locate the different elements, ingredients of the plan. So we have rules to find what's the optimal location on site for each of these elements. So use an agent-based engine for doing this. And then use the generative system to explore different possible configurations, in this case with different types of grids. You strategically test with different locations for the public facilities. And what you want in this case is to optimize the performance. But then what happens? The city is a very dynamic environment. So we are talking about 2 different things. One is what I call the static adaptation. So the moment it gets built, it's optimized for the context. But then the context changed. So we need to find a way of keep updating the solution in response to the environment. And then we have what we call the evaluation system that allows us to rate and rank the different solutions. I'll just show this very briefly so you get the sense for what it does. In this case, we are trying to optimize a solution from the transportation viewpoint. So we can see, what's the best configuration that optimizes access to public transportation, and then you can, rank and compare the solutions. So, but how to get into the dynamic optimization? Let's see an example for a small scale. So this is the design of an exhibition pavilion that uses what we call a kinetic architecture that reacts to the environment. So in this case, we have sensors that detect the shape of things, and the building changes the configuration in response to the objects and the changes detected in the environment. So that's basically the idea. And again, we can design for the environment. So in this case, we have a pavilion that we need, in which we are trying to optimize the natural lighting, the use of natural lighting. And this is more or less how it works. So it's, again, the four systems: formulation, generation, evaluation, optimization. So what you see here is the basic shape of the pavilion. You are going to tessellate the shape. And then once it gets built, it can still change the value of some variables. In this case, is the degree of aperture of the skylight. So you can change the configuration of the system in response to light to optimize the access to natural light. So, but at the urban level, this is much more difficult to do because we can change the configuration of city, or can we? So I'm going to lay down some questions for the other speakers to talk about, because I believe they will answer to some of these questions in their talk. So, what to sense, which data to collect, and how interpret the data, and what are we trying to optimize, and on what we want to act. So basically what we want to find out is what changes in the configuration and how to change the configuration. That's it. Thank you very much.
Okay, thank you, José. That was fantastic. I mean, I think José really opened it up for us in terms of the realm of possibilities in terms of what is smart and what is connected. My background is in a lot of project implementation in terms of bringing people, process, and technology together to implement viable working solutions. So I want to try and sort of focus on some practical considerations in terms of harnessing the power of data in our public community and public environment context. So one of the first messages I'd like to say, convey is, the possibilities are just limitless, right? I mean, you have smart and connected means infinite opportunities, infinite benefits, infinite outcomes. But there's something to be said about taking baby steps in order to get there. It's not going to be a big bang revolution. It's not going to be an overnight thing. So there's mundane things that happen on a day-to-day basis that you can really have a pretty substantial positive impact in terms of the change and the level of integration and the outcomes you can get out of it. So for example, I don't know if most of you may have heard about the Kansas City Smart City program. So they have a series of different use cases that they've implemented. One of the significant accomplishments that they've had over the last couple of years is improving their roadway pothole maintenance. So we all care about potholes, but we don't necessarily think about what goes into actually maintaining them. So they have, through a combination of predictive analytics, using available sensor data, roadway sensor data, traffic data, pavement sensor data, and then by looking at historical patterns in terms of pothole and pavement failure, they've actually come up with a predictive model that predicts the potential for pothole occurrences. And using that, they're actually doing more preventative maintenance as opposed to reactive maintenance. So right there, that actually not only increases the coverage of the mileage that they can get in terms of the number of roadways covered in terms of their annual pothole maintenance, but also substantially decreases their pothole maintenance cost by 50%. So that's like a really substantial benefit there. Similarly, in Ohio, on the Ohio Turnpike, they're actually embarking on a project to use a combination of GIS technology and roadway vehicle sensors and road sensors to actually optimize their snow plowing operations. One of the biggest challenges is it's a control facility. It's the turnpike. It's not too complicated of an environment, but at the same time, they have a hard time ensuring that all lanes within the turnpike segments are actually plowed. And then the benefits are twofold, right? One is ensuring that all the lanes are plowed, and number two, ensuring that you're not wasting your time and your resources by plowing the same lanes again, or salting the same lanes again. So they're embarking on a project to actually, take roadway sensors, vehicle sensors, and then completely automating the aspect of keeping track of what the driver is actually doing. So that's another example of stepwise improvements that can actually make a big difference. And the third bullet point here, really, data is really at the center of it all. I mean, I think we're all here for that reason. The availability of the right data at the right time to the right people in the right format really makes a big difference. Okay, this slide sort of focuses on some of the realities of doing these things. Again, in a public sector environment where you have legacy systems, legacy processes, legacy cultures, and in order to mainstream data-driven decision making, leave alone the government, even in large corporations, it's going to take a huge culture change. One of the examples that I like to quote here is, we're involved with a bunch of work in the transportation operations arena, specifically focusing on highway work zone operations. At the University of Maryland, they have a lab that actually has developed a really awesome system for integrating all kinds of traveler information, traffic data, for providing real-time information on delays and road user costs, so on and so forth. So they have this really neat dashboard they have developed for construction zones, ranking of things, and pretty neat visualizations in terms of what's going on in your network. It's awesome. The data is there, the tools are there, the analytics are there, but they had initially intended for it to be used by construction managers out in the field who could potentially take remedial action when certain service level thresholds were being exceeded. But nobody's using it, because again, the construction managers don't want to be bothered with having to deal with this. They're focused on their project, and they're focused on getting things done. So it's taking a lot of effort to bring about that systematic, top-down and bottom-up institutional culture change. And the last two bullet points really speak to some of the technological realities, right? There's legacy systems, there's a ton of data out there, but they're not necessarily readily harnessable. So there's quite a lot of practical considerations in terms of understanding the limitations and challenges of those legacy systems, and oftentimes when you go into implementing projects, there's quite a bit of upfront work that needs to be done to bring these legacy systems up to par with some of the modern data interchange requirements and standards. The next slide here is sort of a follow-on from the previous topic. Yes, we all want to be smart, but for all practical purposes, you can only be as smart as the quality of your data and the validity and the veracity of your data. Lisa had sort of posed a question to the panelists in terms of, what are some data sources, what are some data collection mechanisms that we would want to engender, so to speak. I believe that with the proliferation of connectivity and mobile devices and everything, we were at the sort of at the initial stages of really trying to really taking advantage and capitalizing on all this data available out there. But the key piece is, I think, to the extent possible, removing the human element away from the data collection is really key. And a practical example in the same context of the snowplow operation is the person, the maintenance worker driving the truck, his responsibility is to drive the truck, salt it, and plow it. We shouldn't belabor them with the responsibility of keeping track of things. So to the extent that we can automate the data collection aspect of it, we will be more successful. And that leads to the second bullet point there, which is the connected and automated aspects of things can really make a big difference here. Doing okay on time, Lisa? 2 minutes, okay. And I think this is sort of my last slide here. It's almost, it speaks to some of the points that José was mentioning. It needs to be context-driven. A city is a dynamic environment. So whatever we do has to be needs-driven and use case-driven. And there needs to be specific understanding of needs, and then the appropriate actuators that use available data to take action in response to those needs. And then it also needs to be agile because it's a changing environment. The environment is changing, the dynamics are changing, technology is changing, so there needs to be a pretty strong dose of agile thinking in terms of how we go about implementing solutions. And at the center of it all is really the notion of design thinking in terms of who needs what, how, and when. So we were just on a Disney cruise a couple of weeks ago. I don't know, if you've ever had a chance to go on a Disney cruise, but it's a pretty special environment there, and I'm sure the parents in the group here can relate to this. When you're traveling with a bunch of kids, you really seek that isolated moments of serenity once in a while. And what they have something called as the Oceaneers Club, where you can essentially drop off your kids, and it's a pretty big facility within the ship. They have these wristbands that they associate to the kids and the parents, and you check them in, and you can pretty much forget that you're going to have to deal with a bunch of kids for the rest of the day. But the key piece here is they've really understood the needs of parents and kids as well in the context of the environment that they're operating. The wristbands actually have RFID on them, and they have remote sensing of exact, so when you go back to pick up your kid, they can tell you exactly where your children are. So you have this pretty strong sense of security that yes, they are being monitored, they are being fed, and they are having fun. So, but of course, that's a controlled environment. It's easier to implement those kinds of solutions. But I think that's where we have to stretch our realm of our thinking in the realm of possibility in terms of adapting some of this design thinking and context-sensitive solutions to our citizens. The last bullet point, obviously, the community needs to be part of it all. They need to be part of the problem definition. They need to be part of the solution identification and the implementation. One example from some of the work that we're doing in Columbus is the Smart Cities program. They have done a tremendous job of actually engaging the broader community, and they're pretty much using industry, universities, research institutions, local companies, and community representatives to essentially drive their Smart Columbus program. They have 3 different tracks. There's a policy track, there's a data and use cases track that's responsible for identifying, developing, and prioritizing the use cases. And then there's a technical track that's actually driving some pretty solid technical decisions in terms of what kind of data platforms to build, what kind of technologies to incorporate. So that's actually going to be critical in terms of making our community smarter and more connected. Sort of conclude some of my messages.
Are there any questions? Yes, please. We have one question in the back while Cleo gets set up.
Sir, you mentioned that in smart cities, all sensor data are sent to cloud. Is that correct?
Yeah, so that's a good question. So specifically with regards to the Smart Columbus operation, yes, they are planning on sending everything to the cloud. I think in Kansas City also, it's going to the cloud.
is that always necessary? Why can't I just do the near data processing and reduce the data bus?
So if I may, I think that is a good question for discussion. It's a little bit broader, so
Yeah.
if you can jot that down and we'll come back to it, please.
Okay.
Thank you.
Perfect.
Thank you. I have a control system in action. Hi. Okay, a little down further. Okay. My name is Cleo Andrews. I'm an assistant professor here in the Department of Geography, and I'm very thrilled to be part of ICS. And I would like to publicly thank Guido for getting me more involved in ICS because it's been a wonderful experience. Please let me stay after this talk. I'd like to talk about multi-scale urban flows, why, what, and how. The good news is we already know where, we already know when, and we already know who, and that is all of you. So we're going to be talking more about connectivity later on, and I want to just show you how deeply you can think about the things that connect places. We often measure people as static entities in cities. We've done this in the US for well over 200 years now, looking at people as dots in the census group and looking at their different races, etc. This paints a very compelling view of urban space, especially for things like segregation, income inequality, etc. What it doesn't tell us is how people move around, how things are connected, whether people actually go across segregated spaces. It mostly tells us where we live. So with flows, we've tried to move on. From this static view. Today we have new data. I've started by mapping a lot of this data in a lot of different countries. Here's an example of commuters in Singapore. So looking at how commuters go from their districts for one another, and this isn't complicated. The thicker red lines mean more people are flowing, and the thinner blue lines mean people are less flowing. I've also mapped, for example, call data records in Africa and Cote d'Ivoire to show how many calls are going back and forth between different districts. And this one was extremely interesting because it shows that despite a Northwest Civil War, or a North-South Civil War, and recently, there's still a lot of communication going between the North and South, and less from East to West. I also enjoy mapping dyadic relationships. So this is an example of mentor and proteges. This is and the little dots are the mentor or the protege households. These are high school students. And then the colored dots are places that they go after school every day to learn different tasks. This was part of a school program in Santa Fe, New Mexico, where they're very artistic. So you can see that as a student, you can do an internship in weight training, or in graphic artistry, or in dance. So they like to incorporate a whole lot of things there. So what I've been doing is curving lines on maps and making them pretty colors. But we need to look at what's really going on behind this data too if we're going to understand connections. So I'm going to show you a couple of theoretical distinctions to how to look at flows a little more deeply. First of all, to characterize flows, we need a new entity called the social flow. This is defined as an agent-based decision to move, telecommunicate, or declare a relationship across geographic space. When we started using flows in geography, we started using hydrology and hydrological networks. Then we moved to power grids, energy grids, etc. Then we moved up to understanding how road networks move along. And then freight, so we weighted those networks for having things flow through the network. And then we got a little bit more advanced, modeling traffic, flights, migration. We got more telecommunications data, and we started measuring how much people are sending information. And now we're moving into a new social realm where we have geolocated data of articulated relationships. So where are my friends, where are my family, etc. And we're moving towards a UV spectrum of this data that we can't really see, we can't really model it, but it is still connecting places. And this data is not new. They've been using it incrementally since the 1940s. When Jay Forrester put a lot of systems dynamics works out there. One of my favorite papers is this paper from 1955 called Hinterland Boundaries in New York City and Boston. And it was done by a director of a grocery store, and he wanted to show where the line was between Boston market and New York market. So he used things like where people were cashing checks from and where people were taking the train from, and he used newspaper circulation. And those things were very innovative back then. But today the data is even easier for us to get, but we're still not integrating it well enough. So this is the second of the third schemas that I've tried to develop. Social flows are started in our brain. We also use a framework to manage flow data from the scale of the mind to massive global flow networks. And this is a little overwhelming to show on one slide, I think, but the point of it is that we really need to map where our data sits from when it exists in our mind all the way up to when we get it as a giant OD network of telecommunications flows or movement flows. Because if you tapped everyone's shoulder, if you were on an airplane, for example, and you went up and down the aisle, tapped them on the shoulder and said, hey, why are you flying today? A lot of those reasons are because I'm going to a wedding, I'm going to a business meeting, I'm going to the best ICS Symposium ever at Penn State. And this decision starts in our brain. And as it moves up the scale, it turns into, we look at our relationships, it turns into social capital, we spatialize that, and then we look at our movement patterns individually, we looked at how those are socially linked, and then when we aggregate all of those, it gets up to these giant OD matrices. So you need to be able to scale from one thing or another. This is not a popular idea with people. It's really hard to convince people to talk about cognition and to talk about logistics in the same sentence, but I think we need to do that. This is my last broad piece here. To model urban connections, we need data integration. We need to use data in GIS models. So I've developed a couple of ways to do this based on some previous literature. And we have different types of ways we can model flows. We can model them as dyadic pairs, as egocentric networks. We can model them by the node roles. So for example, where do the high degree people hang out? Do people with a lot of friends, like Entourage, do they hang out downtown or are they in the suburbs? We measure them as modules as well. Do communities that we find in the networks also live as communities in geographic space, or are they spread out? And then we model them as diffusion, which is the hardest one to visualize. But if something starts with one person and diffuses around, how does that move in geographic space? If I start a rumor or some gossip or some fake news, is that just gonna bounce around State College? Is it gonna go Euclideanly, or is it gonna go to Brooklyn? I'm not really cool enough to have a lot of friends in Brooklyn, so it's not gonna go there. It's probably gonna go to some smaller towns. But maybe some of you will be sending some information to some posh places. So I'm really enjoying integrating some of these ideas into teaching. I really like teaching and service along with my research. So students are now using these techniques to learn about the world. This is an example of a student lab mapping remittance flows. These are online for free from the World Bank, if you're ever interested in it. Their job was to look at the banned countries from the travel ban last year, and looking at what their role was in the global remittance flows. So these are the amount of remittances leaving each of these countries to go to other countries. So if we thwart the economies in some of these places, how is that going to affect the global network? And as a spoiler alert, these countries do send out much, much fewer remittances than they receive. So their role in the global network is to really receive money versus sending it out, given this data. However, as a lot of people who map flows know, the map looks a lot better when you have fewer flows, so I didn't show the haystack of all the flows going on. As one of our other projects, our lab gathers new data on actual dyadic relationships and what they mean for information transfer, travel, cognition, and urban vitality. This is a project I'm especially proud of. It looks at big brothers, big sisters relationships in an urban environment. And I love this project because it shows in a bunch of different cities how these dyads, these interpersonal relationships, are cutting across segregated spaces. And we only look at the segregation usually, but this is really showing what's sewing together the urban fabric. And that's a lot of relationships. And our lab is also trying to create some more theoretical knowledge about social flows, so revisiting distance decay models and saying how do things decay from an epicenter depending on what kind of flow it is. So migrants, for example, they actually go very nearby in this country. I didn't really know that. Versus commuters are actually a little further. Twitter friendships are further, and then flights go even further. So I'll conclude here, and my conclusions are a wish list. So my goal for all of us to discuss today is to better characterize place and infrastructure by what flows in and out of it instead of what's just here. The objectives for this goal are to work with interdisciplinary teams because we really, really need different researchers here, definitely. To create more integrated software environments, working at non-planar flows in a GIS environment right now is kind of a nightmare for the students. I don't mind it as much, but it can be a lot better. So I call on people to maybe work on that problem. And to improve computational power and data access, which I think is a big mission of ICS, and it really bolsters our ability to find out these new problems. Okay, thank you.
Clarification questions for Cleo? Thank you.
All right, so I'm going to talk for 11 minutes and 30 seconds because I'll be using a modified version of a Quercia. Do you know what is a Quercia? You've got 20 slides, 20 seconds each slide. I do 30 slides at 20 seconds each, and this slide is going to automatically transition. There you go. So I don't get to talk about where I work, which is Bell Labs. Bell Labs is an industrial research center. The headquarters is in Murray Hill. I do work in the area of smart cities, in particular in data. And you know, the typical thing of smart cities is that what is a smart city? It's a city in which when you're going to work, when you're going to go to work, you're always on time. When you go shopping, there is no queue. And you feel really safe because there are CCTV cameras around you. And so it's about safety and convenience. But there are other things that make a city not only acceptable, but make it great. Like, for example, quality of life, beauty, happiness, and other things. So our goal is to quantify those things. They're very hard to quantify. So let's start with the first one. And I'm so sorry if I'm repeating the talk that I did give yesterday, so I apologize to the people who came. Also today. So the first thing was about trying to quantify community engagement. It's a very complex problem, and it's very difficult to quantify. So instead of spending all your life looking at literature of community engagement, please play with our 59 prompt cards that you can find online on goodcitylife.org/6x. How did we come up with these 59 cards? We did an extensive literature review across different fields, from biology to computer science. We consulted experts, and we came up with 59 prompt cards, which are basically techniques that you can use to start a new community garden, or to start a community on campus, all sorts of things that you might think about, or even a community online. So both online and offline might work. And that's basically how the game is going to look like online on goodcitylife.org/6x, where you have your own scenario, you input your scenario, like, I don't know, I would like to do a data sharing community across Penn State, and I saw a poster about it today, and then you're going to get prompt cards, and you might like or you might dislike some of the prompt cards, and you get a summary after 40 minutes of all the great ideas that you have generated to actually create a community and to have sustainable engagement in that community. Example number 2, urban vitality. So what did we do? How many people know Jane Jacobs? Please be fast, thank you. Jane Jacobs is an urban sociologist in the 60s. And basically she was about trying to quantify urban vitality. We tested her theories. And how did we do that? We look at call data records. From call data records on your mobile phone, we can estimate the number of people that are in different areas of the city. We have done that for 8 cities in Italy with the main operator, and we actually tested the Jane Jacobs theory on on the left-hand side, like employment density, intersection density, they're all about land use, static things, density of people. They actually predict something that is very dynamic, the vitality of the city, the pedestrian activity. Then, of course, instead of using only call data records, you can use this other kind of data, like your Fitbit device. And we use not Fitbit, but Nokia health devices, and we done some analysis in San Francisco and London, and we look at the heart rate or number of steps that people take and for a year. And what we found out for our heart rate, please be worried, is that during the Trump election, your heart rate went a bit up. And that's not causal, of course, it's just correlation, it just happened to be during the Trump election. And then you can look at other sources of data to actually monitor the health levels of the city. Not only Fitbit, but you can look at your Fidelity card. So we look at Fidelity cards for the main grocery store in London. For each zip code in London, we have what people buy and their likelihood of diseases, because we have GP prescriptions. And what you can map, for example, you can map nutrient diversity, right? Do you actually buy things that are very diverse in terms of nutrients or not? That's actually the strongest predictor for absence or presence of diseases, like, for example, diabetes. And you can see here on the y-axis the probability of getting diabetes versus the nutrient diversity at different areas in London. You can see that the more diversity is, the better it is in the community. Whereas if you consume a lot of calories, that's not really good, right? So actually you can, now all of a sudden with this kind of data that is not meant to track healthiness, you can track healthy communities. Then the other thing is that you can quantify really fuzzy concepts like Lisa mentioned, right? Like beauty. How do you do that? Well, you can do pairwise comparison. And let me get to that pairwise comparison. So if I were to ask you between these two pictures, which one is more beautiful and makes you happier, who says A? Please don't be shy. Thank you very much for your cooperation. Who says B? There you go, I've cherry-picked the example to actually make the point that beauty is a subjective concept, and yet there are certain things upon which we agree. So we are after trying to quantify these things, and we did a game where people basically were doing left and right, which is more beautiful, quiet, and happier, and we could rank, based on the pairwise comparison, and thousands of people playing the game, the Google Street Views in London by beauty, by quietness, by happiness. And of course, Google Street Views are points on a map. So what do we do with points? We connect them. So why on earth do you want to connect points with beauty scores or with happy scores? Yes. Those are beautiful points. So because we built a new mapping tool, that instead of giving you the shortest path from UCL to Tate Modern in London, 20 minutes, is going to give you a 22 minutes path, so a short path that makes you happier, it's beautiful, and it's quiet. All right, so basically you can do all sorts of things, and another thing that crazy stuff that we were doing is that you can use deep learning, and deep learning for images. You can start from a Google Street View, you can feed beautiful and ugly images, and you can ask the model to actually recreate a beautified version of the original image. And you can look at the differences, and then you can say those are the sort of very cheap intervention to make it beautiful what you have there. Does it work? Not yet, but we are working on it. So basically the idea is that with a click of a mouse you can beautify the entire world, and you can increase those urban qualities that we like and make a place great. So if you go on facelift.datadissonance.org, you're going to see the examples for which some of these things work and some of these things don't work. So you're going to find a map of Boston, and then you're going to click, and you're going to see basically the original Google Street View of Boston and the beautified version of it. And then you can compare the elements that are inserted for beauty. Then I think just to conclude, so the idea is that we are mapping what people find visually pleasurable, and we are mapping the other senses, hopefully, like for example the senses of smell, the senses of sound, and healthiness from different data sets. No, it's not to conclude, so I have time, Lisa. So apparently, I mean, my picture is going crazy. Okay, so the other thing you can do is you can actually map smell, right? So why on earth would you want to map smell? Because your nose is a big data machine. It's basically can distinguish, in theory, 1 trillion different kind of odors. And yet, if we look at the urban planning, so the guy who actually deals with smell in London is one for a 10 million city, and he is looking at bad odors, right? That's it. That's a state of the art in urban planning. So we said, okay, can we actually celebrate also the good odors of people? But we need to capture them. And we use Kate. So Kate does a PhD at the Royal College of Art on smell walks. Basically, her PhD is going around the world, hopefully not in business class, but going around the world and then actually asking locals to smell stuff. And these locals will actually collect these smell descriptors. And what do you do with smell descriptors and keywords? We match them. So we basically look at all picture tags, picture keywords that people have on Flickr or on Instagram that georeference, and we match the ones that actually reflect urban smell. So we have 380 words from Kate that do reflect urban smell. And then you can do all sorts of stuff, like Clio does, right? Graph and things, and you can look at which words co-occur together. And you discover that if you do this graph, you can have all the animals word together, all the nature words together, all the mission and traffic word together. So why you want to do that? Because now you don't only have a list of words, but you have like categories and subcategories. So you can create for the first time the urban taxonomy of smell, right? And what do you do in the taxonomy? We feel relieved because with the taxonomy we can actually study stuff, right? Make order in something that is very disordered. So one thing that we did, we worked with epidemiologists to actually make sure that since we are capturing the smell out of picture tags, they actually reflect what you find. And actually, if you have a lot of nature words, you don't find nitrogen dioxide, negative correlation. If you find a lot of traffic words, you have a strong correlation for nitrogen dioxide, as you would expect. For example, this is the map of London. You see a beautiful river. We are looking for words related to traffic, so you can map the trafficscape of the city. And of course, the second category in the wheel, right, we have 10 categories, is nature, and then you can map the entire naturescape of the city through picture tags. And if you're hungry, at some point, you can map the nature, you need to take a flight to London, but then you can map the entire futurescape of the city. So we called this project Smelling Maps, and we have done another project about sound in a very similar way, and we call it Chatty Maps. And not very creative in the names. Then if we can, so you can find on goodcitylife.org different maps. I think 12 maps for different cities. And this is London. You can search for a street, and you can basically look at the smell profile here of each three segments. And just to conclude, so the idea here is not only to map for different cities, for the same city, what people find visually pleasurable, but what they hear, what they smell, and ideally is to relate these different layers to the well-being of people. Thank you very much.
Thank you very much. So at this point, we will take clarification questions, but also any topics to sort of lead us into discussion. Anything from the audience? Okay, then I'll open it up to the panel.
Well, everything was clear. Great.
I have a question. I work with a company that has a large data set of transportation in London and around the world, and how do you, as a policy issue, balance the need for creating this data and harnessing the power of this data and balancing, and especially from the lens of transportation, security, community security, and issues of privacy? We've seen a lot of things recently where data is really helpful and really cool, and also can be used incorrectly. It's kind of a hard question here.
Yeah, I mean, since you mentioned London, there was a recent conference organized by the London City Council about the data trust, right? So the idea is that, and that's one of the things, I'm not sure I can talk about it, but that's one of the things that my company is struggling with, because they're very much into smart cities. And the big question is, who is going to create this data common thing? It's in infrastructure. It does cost money. And because if you don't have the data, then you cannot offer services on top, right? You can offer transport, you can offer air quality services and so on. So there is no real answer to that. The answer of London is you have a data trust that is actually managed by the city. And then there might be some technological solutions with which people can give in anonymous ways their data and for services that can be powered by aggregate data. So for example, for transport, you don't really need to have my travel card every single day, A to B, and the timing. You might need the aggregate thing, right? So if that is the part of the service, then there are ways to actually have aggregate information coming from people, right? And I think if people see the benefits of it, then they can compromise on the privacy, because you're asking basically a trusted authority. Then I don't know, different countries trust the government versus businesses, and that's a big thing. But you can trust, right? Because you're getting something out of it, and people are going to ask you just to provide aggregate information.
In the case of London, how much community input is involved in that decision making?
Well, London is a big and busy city. It's like New York, right? So there is not much consultation process going on. It's more like trying to figure out where the technologies are, what can we do. Like, for example, related to the question of before, like, can we have a personal container of our information, where I've been, where I've moved, and this personal container can release selectively information that is good enough to power that service, right? So it's more like a conversation between academics and differential privacy is one of the techniques that people are exploring too, but it's not much a consultation process from the bottom up.
Thank you.
No worries. Then I don't know if
Would
you guys.
anyone else like to address the question of security and privacy?
Yeah, I'd just like to add, I think what Dan said is spot on right there. I mean, so to the extent that the data has benefits for the broader community, that's one of the biggest challenges in terms of practically implementing these integrated data exchanges. And going in at the early stages of planning and implementing these systems, security, privacy is a big part of the discussion. Anonymizing the data, masking the data to the maximum extent possible is a key requirement as you go into these.
Question over here?
This is a question for the whole panel. I think we're talking about smart communities, and I wanted to talk about a theme that seems to show up in all the presentations here. The notion of smart refers to an algorithm, like the algorithm of trying to get home for supper after work, for example. Then algorithms lead to data, data leads to flows, flows lead to infrastructure. Infrastructure usually means built environment, which defines a community. What I wanted to ask everybody is I'm hearing specific focus on each one of those levels as we connect smart to communities. But in that, I haven't heard any discussion of the overlap and possible instabilities between them. And I want to broach the problem from something I'm struggling with in an area of autonomous vehicles, that if I throw out an autonomous vehicle algorithm today, I might fundamentally break the community in the sense that I suddenly lower travel costs. Nobody cares that they live far away from a community anymore. They're going to start commuting significantly, and the community can try to respond quickly to that change in algorithm and do so through data, connectivity, infrastructure, and even the definition of community. But it creates this feedback loop and chasing of the structures to each other in terms of how they're designed and used. Can the panel discuss that? Even among the panel, there seems to be a disconnect between, are we talking about algorithms, data, flows, infrastructure, or communities, and how can we have a good dialogue as a community to look at all of those together?
I think the first thing we need to agree on is what we are trying to optimize. So from Dan's talk, I think he was trying to optimize happiness. I think it's a very good thing to optimize. But you know, there are community is a very complex entity, and I think really to agree on what we want to optimize is the first step. Obviously, happiness is the ultimate goal, but I think it's hard to get there immediately. So we have to, we want to optimize transportation costs, we want to optimize the cost of operation of the city. So there are different levels of optimization that we can look at.
I don't know if you can hear me.
Yeah.
Okay, yeah, I think you can. I think that's a really good question. I think that one issue is having the definition of community mean in one geographic space. I'm personally very excited about autonomous vehicles. I'm sad about them because I think that sometimes they might minimize our social interactions in public transportation, which is a really democratizing thing to do. The public transportation is. I do think that, thank you, that they are going to help things like long distance relationships, which when people are meeting online, they meet their person who lives further away. Having these autonomous vehicles is going to help foster romantic relationships. It also might help with commuting to a job where you're limited by where you live, for example, and you can now commute to that job. And so having a new type of community, for example, we're seeing a lot more virtual communities online. For example, online gaming, they call that a community, but those people are all over the world. So I think that we all have our own definitions of community here, but it's going to be, I think that it's a really interesting thing to be working on right now, and it's going to change those definitions a little bit.
Yeah, so me coming from the transportation industry, so to your point, there's a lot of research, a lot of work needed in order to truly understand the spectrum of impacts that you can expect from autonomous vehicles. I mean, that's really far-reaching in terms of acceptance and proliferation and market penetration and such. But in terms of fundamentally changing, people's attitudes and behaviors, it might be something as substantial as the advent of the freeway system, way back when. And I think it's going to be pretty huge. But there's a lot of work that's being done though, and a lot of more work needed to be done. So.
Yeah, I don't have an answer, of course. But the first point I had is that the introduction of the car, not even of the autonomous car, was a disaster for US, right? So then you see all the highways running around in LA, and that's the worst possible thing you can have for connected communities, socially connected communities, right? Then how do you deal with that problem? I mean, from a service perspective, the most effective things that, from a company perspective, the most effective thing that I saw is the hierarchy of needs we were talking about yesterday, right? So you can actually optimize for basic needs, the transportation skills, up to self-authorization. So if a new technology that autonomous cars, right, allows you to cover the basic needs plus self-authorization, that's something. And how does it allow to do that? I mean, that's something that I think it would be an interesting guide, right?
Well, mine was related. I'm just sorry about each of you took a lot of data and layered it to come up with specific ways of viewing community, right? But each of these is a layered system that's somewhat isolated from the others, but clearly they're not isolated. We all experience each of the things we discussed. So I think I'm taking a different approach to the previous question and asking, is there a way that these views of the world can be complementary or integrated at least at the margins to help with developing cities or communities, right? So looking at the smell trail and looking at where are the current motions of people and how do we improve the infrastructure and the built environment and the transport among all of those to make a happier community, right?
Yeah.
So
I think more important than trying to optimize anything now is to understand how the different variables are related to each other, so that we understand if we change these, what's going to be the effect on the others. And that's where I think big data can help a lot, because things are actually a very complex and dynamic process, and it's poorly understood so far. So like, for instance, we're trying to optimize transportation. But if you optimize transportation and you get very quickly from one point to the other, you might be minimizing the opportunity for social interaction. For instance, the other day, my plane got delayed. I was at the airport, very bored, and I started talking to the other passengers. And it turns out that I met someone who was a publisher. It was very helpful for me to meet her. So sometimes you want to get delays. So it's, what I think is more important than optimizing is actually, to understand the connection between different aspects of the city.
Yeah, I think the point I'd like to make is, you raise a very important point, and it behooves us to actually look at everything in combination with each other. They are isolated systems in their, when you look at them, individually, but then the benefit and the value of the data really comes into play when you bring all of this data together. And this speaks to what I think Cleo was referring to at the end, which is, broader computing power, integrated data from across multiple systems. That's what's really going to allow us to truly understand the dynamics across these multiple subsystems operating within a larger urban environment. So I think it's a requirement, period.
I think, I'm biased, so I live in my filter bubble of things, and so what I'm going to say is that the solution is to collect as much data as possible, to curate data, right? Because that's the only way that you can actually measure. But not everything you can measure counts, and not everything you can count matters, right? The problem is that in a lot of technology circles, the idea is that data you're going to have huge data, big data, and I think the future is going to be about data scarcity, right? And the paradox is that nobody, except a few players in the world, like 2 or 3, are going to have data about communities and people, right? Nobody. So we're not going to have health data, so only one provider is going to have that, and it's going to safeguard that data. It's not going to be shared. So the vast majority of people, basically totality, we are going to live in a data scarcity world, and we need to deal with that. Whereas the community, the developing models that they do rely on lots of data. So that's a sort of paradox that I can see coming in 5 years, that people will realize, oh, I don't have actually, and that's what actually Cleo is doing, right? So she's actually doing like very well curated data of flows of people, where people go, what kind of places are processing relationships. And that's a really painful and long process. Why? Because nobody has got that data, right? So data that matters is very rare.
I think that's very, very forward thinking. I hope that the data apocalypse probably won't happen. On the flip side of that, I think that we owe our governments a lot of credit. Them opening up a lot of their data to us has made them open to risk, has made them open to a lot of criticism. Saying, instead of waiting on the train platform, being like, I wonder when my train's gonna come, they're telling you it's late. They're telling you our station's closed. They're telling you, we messed up here. And that sort of transparency between government and people, I think, sends a little bit of a peace signal and a nice message between the governments. So I think that a lot of the private sector companies still own a lot of the interesting data, but our governments are also doing a really good job of giving us a lot more data that we can crunch in a lifetime.
So we are at 12:30. I remind everyone that lunch is upstairs, and ask you to thank the panels, but if there are any remaining questions, we can take them. And then we've really touched on in the last couple of comments who's creating the data and how do we get past the scarcity of data. There was a question in the back regarding the how and specifically cloud necessity, but we also touched on open source, and so I don't know if the panel would like to talk a little bit to that how.
They can give closing remarks.
There you go.
So responding to the cloud question, I think it's just a matter of scale. It just comes down to a matter of scale, and the cloud providers have the tools and the platforms and the ability to scale up in a more efficient manner so that we as problem solvers can focus on solving the problems in terms of the meeting the needs of our citizens, and then the people that are experts there can actually handle the substantial big data management and storage and processing needs that they're really good at doing. So that's what it comes down to. So
I think that question was a little different. I think what he was asking was, do you really have to collect and store all my data on the cloud? I don't want it stored on the cloud. It's a big thing.
So that's
So it's sort of a data resistance thing that you guys want to collect logically and get accurate data, make your decisions. But if people are concerned about giving you any data, then that's going to create loggerheads to deal with. So how do you make people feel comfortable about giving their data to you and storing it somewhere so you can use it?
Yeah, that's a fair point. Anybody has any thoughts on that?
So, yeah, I'm not sure that's exactly the good interpretation that what we are trying to actively avoid, and we're pretending not to understand. But basically the idea is that it would be very nice if people wouldn't give out their data, and we would live in a no data world and not services at all, right? And then you have other nations where people share data, and then they would say. So the funny thing about this data, I mean, I would love to have, there are technologies at the moment where you have your own personal containers, you can selectively share the data that will power service, like I was saying before. But without data, you don't have any service. That's a compromise, right? So, but if the data is used for the purpose of the service, then it's good. If it is used for something else, like Facebook collecting all your calls in the time of when you call on your phone, that's totally out of any reasonable use of the data. And the funny thing is that in US, I mean, I'm very huge supporter of data tax, so in the sense that actually these data commons for cities, they have to be created by the public sector, right? As much as roads are created and so on. So those are going to be the roads of the future, and you sort of need money to do that. But the funny thing is that in US, the government is really, people look at the government and it's very accountable, right? So with the privacy invasion, after the sort of terrorist attacks and these kind of things, oh my God, the government is collecting data. Ain't nobody's talking about a Facebook collection, a massive experiment, a social experiment is going on there, right? So a big corporation is collecting much more sensitive data. Is not accountable. So it's really, I can't say anything intelligent about it.
Personally, I don't feel comfortable having my data somewhere else that can be accessed by anyone, but I think it's a matter of perception. If we perceive that the advantages are greater than disadvantages, maybe we are willing to release our data. But I think it should be up to each of us to make that decision. That's democracy.
Yeah, I just want to sort of draw off of that. I think it comes down to what's in it for me, right? So that's it. So the value of data grows exponentially when you actually combine it with other related data sources that allow you to draw intelligent patterns and decisions from the data. So actually, that's actually a relevant thing that's going on in Columbus again. There's insurance companies, there's big businesses, everybody part of that Smart Columbus initiative, and they are providing their data so they can that can be matched with other publicly available data sources, and then they eventually want to create data products out of this integrated data, which will then be released back out to the same people providing the data with more value add there. So I think what's in it for me is a big part of the equation.
Thank you very much. Thank you to Guido for organizing this session, to all of you for coming to ICS Day, and especially to our panel. Thank you.